The gravity-defying mystery of magnetic hills. Ever seen a car defy gravity? Imagine parking your vehicle, putting it into neutral, and watching it slowly, impossibly, roll uphill. It's a sight that challenges everything we know about physics and the natural world. This isn't a scene from a science fiction movie. It's a real-world phenomenon that has puzzled and amazed travelers for centuries. You're not alone if you find this concept utterly mind-bending. This incredible experience is known as the magnetic hill illusion. It's a place where the laws of physics seem to take a vacation, leaving us to wonder what hidden forces are at play. What exactly is going on here? Let's dive deep into this captivating mystery. We'll explore the setup, the science, and the sheer wonder of these gravity-defying locations. Prepare to have your perceptions challenged and your curiosity ignited. These enigmatic hills are not isolated anomalies. They exist in numerous locations across the globe, from the rugged landscapes of Canada to the ancient routes of India. Each site offers its own unique charm and an equally baffling experience. You can find them in places like Moncton, New Brunswick, a famous Canadian spot that draws thousands of visitors annually. Or perhaps you've heard of the magnetic hill near Ladakh in Ladakh, India, nestled high in the Himalayas. Even closer to home, there are similar sites in the United States, Australia, and many European countries. Despite their diverse geographical settings, they all share a common, perplexing characteristic. They are typically situated on what appears to be a slight uphill slope, yet when you stop your car, it seems to roll against the incline, moving upwards, as if pulled by an invisible hand. This apparent uphill climb is the central paradox. It's the visual trick that captures our attention and makes us question our understanding of gravity. The very essence of the illusion lies in this deceptive appearance. That deceptive appearance is the key to understanding magnetic hills. The illusion plays directly with our eyes and, more importantly, with our brains. Our minds are constantly trying to make sense of the world around us, often relying on visual cues and past experiences. We are hardwired to expect certain things. For instance, we instinctively know that objects, especially vehicles, should roll downhill when left to their own devices. This fundamental understanding of gravity is ingrained in our perception. So, when a car appears to go against this fundamental law, rolling uphill without any apparent propulsion, our brains are instantly confused. This cognitive dissonance creates a powerful sense of wonder and disbelief. It's a direct challenge to our ingrained expectations. Think about it for a moment. You put your car in neutral, release the brake, and brace yourself for the expected downhill roll. But instead, you feel a gentle push, and your car begins to ascend. It's an experience that truly defies logic. How is this even possible? Is it some form of magic, a localized anomaly in the Earth's gravitational field? Or perhaps something more mysterious? The answer, as often is the case with such phenomena, is far more grounded in reality than you might imagine. The true explanation for magnetic hills lies in the power of perspective. It's all about how our brains interpret the visual information presented to them. The surrounding landscape is the primary culprit in creating this elaborate visual trick. Trees, distant horizons, and even the configuration of the road itself all contribute to a distorted view. These elements conspire to create an optical illusion, making a downhill slope appear to be an uphill climb. Our brains, trying to make sense of conflicting cues, get thoroughly tricked. Imagine standing on a perfectly flat surface, but with a row of unusually tall trees on one side and a distant, sloping horizon on the other. Your brain might struggle to accurately perceive the flatness, instead interpreting a subtle incline where none exists. Magnetic hills exploit this very vulnerability in our visual processing. It's much like a magician performing a trick. The magician uses misdirection, drawing your attention away from the actual mechanism of the illusion. A magnetic hill uses the entire environment as its stage, misdirecting your perception of the true gradient. The subtle interplay of these environmental factors creates a powerful and convincing illusion. The road might actually be sloping downwards, but the surrounding terrain makes it seem like you are looking up a hill. This is where the magic, or rather the science, truly happens. So what's the actual science behind this captivating phenomenon? The most important thing to understand is that there is no actual magnetism involved. Despite the name, no hidden forces are pulling your car uphill. There are no strange gravitational anomalies, no secret alien technology, and certainly no paranormal activity. It's purely a clever arrangement of visual cues that manipulate our perception. The brain does the rest, filling in the gaps and making assumptions based on incomplete or misleading information. This is precisely why it's called an illusion. It's a trick of the mind, not a trick of physics. Our brains are incredibly adept at pattern recognition and making quick judgments. But sometimes, these shortcuts can lead us astray. The human visual system relies heavily on reference points to determine slopes and distances. When these reference points are themselves misleading, our perception of reality can become distorted. On a magnetic hill, the horizon line might be obscured, or the surrounding terrain might slope in a way that contradicts the actual road gradient. For example, if the land on either side of the road slopes steeply downwards, it can make a gentle upward slope of the road appear much steeper, or even make a gentle downward slope appear to be an upward one. Our brains struggle to find a reliable horizontal reference. The horizon line is one of our most fundamental visual cues for determining level ground. When the true horizon is obscured, or itself slopes, our brains can become disoriented. On many magnetic hills, the surrounding landscape, such as hills or mountains, creates a false horizon. This false horizon can be tilted, leading our brains to misinterpret the true slope of the road. If the false horizon appears to be sloping downwards, a road that is actually sloping gently downwards might appear to be sloping upwards relative to that perceived horizon. It's a subtle but powerful effect. Another contributing factor can be the absence of clear, consistent vertical references. Trees, buildings, or utility poles that are truly vertical can help us gauge the slope of the ground. However, if these references are sparse, or if they themselves are growing on sloping ground, they can further confuse our perception. Imagine a road winding through a valley, where the sides of the valley slope steeply upwards, even if the road itself is going downhill. The overwhelming visual information from the surrounding terrain can make it feel like you are climbing. Your brain prioritizes the larger, more dominant visual cues. This phenomenon highlights how much our perception of reality is constructed by our brains, rather than being a direct, unfiltered input from our senses. Our brains are constantly interpreting and making sense of the world, and sometimes they get it wrong. While the car rolling uphill is the most dramatic demonstration, the magnetic hill illusion can affect other perceptions too. If you try walking on these slopes, you might feel an unusual sense of effort, as if you are indeed walking uphill, even when you are actually descending. Some people report feeling a slight disorientation or an odd sense of balance. This is because your proprioception, your body's sense of its position in space, is receiving conflicting signals from your visual system. Your eyes tell you one thing, while your inner ear and muscle sensors tell you another. This cognitive conflict can be quite unsettling, adding to the mystique of these locations. It's not just a visual trick, it's an experience that engages multiple senses and challenges your fundamental understanding of your own body's orientation. The illusion is so convincing that for centuries, people have attributed these phenomena to supernatural forces. Tales of ghosts, ancient spirits, or even strange magnetic fields emanating from the Earth's core have been spun to explain the inexplicable. These stories, while captivating, ultimately miss the scientific truth. The human mind is wired to seek explanations, and when a simple, logical one isn't immediately apparent, we often turn to the extraordinary. Magnetic hills are a perfect example of how our brains can be so easily fooled, leading us to believe in phenomena that don't actually exist. The study of magnetic hills offers a fascinating insight into the psychology of perception. It demonstrates how easily our brains can be manipulated by environmental cues. This isn't a flaw in our design, but rather a consequence of how our brains efficiently process complex visual information. Our brains are constantly making educated guesses based on past experiences and available data. In the case of magnetic hills, the visual data is misleading, causing our brains to make an incorrect guess about the slope of the road. It's a testament to the power of context in shaping our reality. This phenomenon is closely related to other optical illusions, such as the Ames room, where distorted perspectives make people appear to grow or shrink, or the Ponzo illusion, where converging lines make identical objects appear to be different sizes. All these illusions exploit the brain's reliance on contextual cues. Understanding these illusions helps us appreciate the complex processes involved in vision and perception. It reminds us that what we see is not always an objective truth, but rather an interpretation constructed by our minds. Our brains are incredible pattern-matching machines, but they can be fooled. The experience of a magnetic hill is a powerful reminder of this cognitive process. It forces us to confront the limitations of our own senses and the sophisticated ways our brains try to make sense of the world. It's a humbling and enlightening experience all at once. So how can you experience this incredible illusion for yourself? The process is surprisingly simple, yet profoundly impactful. When you arrive at a designated magnetic hill, you'll typically be instructed to stop your car at a specific marker. Then, you shift your car into neutral and release the brakes. The anticipation builds as you wait for the expected downhill roll, but instead, you'll feel a gentle, undeniable pull as your vehicle begins to move. It slowly, steadily rolls uphill, seemingly defying all logic. Many locations even have a painted line or a sign indicating the starting point of the illusion. This ensures that you are positioned correctly to experience the full effect. It's a moment that often elicits gasps of surprise and laughter of disbelief from first-time visitors. Some people even try to prove the illusion by pouring water on the road, only to watch it flow uphill. This further reinforces the visual deception, making the experience even more convincing and perplexing. It's a simple experiment that powerfully demonstrates the illusion's strength. The best way to truly understand a magnetic hill is to visit one. No amount of explanation can fully capture the feeling of witnessing your own car move against gravity. It's an experience that stays with you, prompting reflection on how we perceive the world. The enduring popularity of magnetic hills speaks to our innate human curiosity and our fascination with the unexplained. Even after learning the scientific explanation, the experience itself remains captivating. It's a playful challenge to our understanding of reality. These sites have become popular tourist attractions, drawing visitors from all walks of life. They offer a unique blend of entertainment, education, and a touch of mystery. It's a chance to witness something truly extraordinary, even if the explanation is perfectly ordinary. For students, magnetic hills provide a tangible, real-world example of optical illusions and the psychology of perception. They offer a hands-on lesson in critical thinking and the importance of questioning what we see. It's a memorable way to learn about science. For travel enthusiasts, they represent a quirky and intriguing destination, a chance to experience something off the beaten path. They are often nestled in scenic locations, adding to the overall appeal of the visit. It's a unique story to tell, and for the curious minds among us, magnetic hills are a reminder that the world is full of wonders, both natural and perceptual. They encourage us to look closer, to question assumptions, and to appreciate the intricate workings of our own minds. The next time you hear about a magnetic hill, or perhaps even visit one, remember this: it's not magic, it's not a supernatural force, and it's certainly not a breakdown of the laws of physics. It's a clever trick of the eye, a testament to how easily our brains can be fooled. It's a powerful demonstration of the subjective nature of perception. Our reality is not just what our senses detect, but what our brains interpret and construct from that sensory input. And sometimes, that construction can be wonderfully, delightfully wrong. These illusions serve as a valuable lesson in critical observation. They teach us to be skeptical of our initial impressions and to seek deeper explanations. They remind us that appearances can be deceiving, and that true understanding often lies beneath the surface. So if you're looking for an experience that will challenge your perceptions and spark your curiosity, seek out your local magnetic hill. Prepare to be amazed, amused, and perhaps a little bit humbled by the power of your own mind. But what other illusions are out there, waiting to be discovered? What other clever tricks does the world have up its sleeve, ready to challenge our understanding of reality? The journey of discovery, it seems, is endless beyond known.